All right, I've hinted at this in the past, but now we'll formalize it. A two-sided limit, in other words, the limit as x approaches a value, so in this case we're calling it c, only exists if both the left and the right limits exist. So you need to have both a left and a right limit in order to say for sure that there is a two-sided limit. So we need to start being very careful with the notation that's given as well as the notation that we use. For example, I have four problems here, 7, 8, 9, and 10. In 7, 9, and 10, we're looking for two-sided limits. But in example 8 there, we're only looking for a one-sided limit. So once we start adding some words to these problems and we start actually looking at situations where we're talking about velocity and position and light waves and all the good stuff that calculus brings us, there are times when we care about both sides of the function. And there will be times when we only care about one side. So we need to be very careful with the notation that's given and the notation that we're using. In this case, since these are just limits, here they are, evaluate them, it's not too crazy. But again, each one of these notations has a meaning. So I'm going to do all four of these on the calculator. I already have them programmed in. If you would like to pause here and program them yourself, feel free. We'll start with number 7. So I want to look as x goes to positive 2. And again, I already have mine programmed. So let's go ahead and add a graph. And scroll on up. So here is my graph. I care about positive 2. And I care about it both from the left and from the right. Because again, they're asking me about a two-sided limit. So since I'm looking at this function as it approaches positive 2, note that there's nothing crazy here. There's no jumps, there's no weirdness. The graph might not actually be defined at that point, but it doesn't matter. Even without a table, it is pretty clear that this graph from both the left and the right is approaching the value 2. If you want to pull up a table to double check that, you certainly can. Again, the tables are a bit cumbersome because you have to go ahead and set them to be ask instead of auto. And then you'd have to, do like 1.997, 1.998, 1.999 to see that it's approaching the value -2. But again, if you can see it clearly on the graph without the table, I recommend avoiding the table. So this graph approaches -2. That is a two-sided limit because it happens both on the left and on the right. Now in example 8, they just want us to look at this function from the right-hand side. So they want to see as x goes to -1 from the right. So we don't need these two to match up like we had in number 7. I just care about that right-hand limit. So if we take a look at this graph, again, I care about when x gets closer and closer and closer to -1, which I have highlighted in yellow there. Since we're talking about a right limit, we're coming this direction. So as x gets closer and closer and closer to -1, note that this function shoots down to -infinity. Since we're talking about just that right-hand limit, this has the value -infinity. Again, we're only talking about the right there, so it doesn't matter that the left and the right didn't match up. We don't care about the left-hand limit because they didn't ask us to care about the left-hand limit. Taking a look at number 9, now we're back to looking at a two-sided limit, so we'll go ahead and do that next. Now we care about x being -4. So I have my graph set up here. This is one where we want to be very careful because at first glance, oh my goodness, it looks like this one goes up to infinity and down to -infinity. Be careful. We cared about x going to -4. 1, 2, 3, 4. This x value right here. For this reason, I really like the Desmos feature. With Desmos, it's really easy to see the y values as they relate to x values. It can be kind of difficult on a graphing calculator. This is a problem where it might be useful to use the table. So taking a look at this graph, there we go. Taking a look at this graph, it appears as both on the left and the right-hand side. Wish they gave me more colors. We'll do red for a second. both the left and the right-hand side appear to approach the same point, it looks like it's approximately 4. Again, this is one of those problems where a table is probably worth the hassle. Again, a bit cumbersome because you have to set it to ask and then go from there. We wanted x getting close to -4, so we want to look at numbers like -3.997, -3.998, -3.999. And at first glance, I was like, oh no, but keep in mind, right now that's F1. I stored this graph as F3. So we see here for sure that at least on the right-hand side there, this thing approaches 4. The graph lets me know that, yeah, the left and the right do both meet there. So good to go. This graph is going to have both a left and a right-hand limit of 4. So the whole thing, the two-sided limit, will also be 4. So in number 9, everything worked out quite nicely. Let's take a look at one that doesn't. In number 10 here, we're going to get a two-sided limit that doesn't work out. So I need to look both on the left and the right side of the x value, 3. So x is going to be 3 right here. So this time it is the asymptote. And if we look on the left-hand side, that graph goes down to -infinity. On the right-hand side, it goes off to +infinity. So once again, this is a two-sided limit that does not exist, D and E. So we don't want to lose that section 1 idea that some limits don't exist. In this case, this two-sided limit does not exist. There are 2 one-sided limits that do exist. So I could say that the limit as x approaches, what was it, 3 from the left, that does exist. In this case, it's -infinity. So you could talk about left and right-hand limits. This one would be +infinity. But again, because those don't match, the two-sided limit doesn't exist. So here we had a couple examples where I use a calculator. I also want to jump over, look at some on Desmos, and then bring in Wolfram Alpha again, just because it's fun to have a computer do the work for us. So we'll go ahead and close this video out. It's already fairly long. See you soon.